This will be on integration by partial fractions. So here's our procedure. Up front, sometimes if you have a fraction in integrand, you've got to divide first. If it's an improper fraction, that is if the numerator is of equal to or higher degree than the denominator. So that would be an upfront step you'd have to do, and then do partial fractions with what's remaining. Now, as far as the next step, splitting up the fraction, the only type you'll see on the AP test is a non-repeating linear. So that's an easy one. There's something called the Heaviside method, which you can use, but I'm not going to go over that now. We'll look at some that are a little bit more complicated. If you need to review that, you can go to the same place you found this particular lecture, but go to the math analysis file and look for partial fraction decomposition. There's a mini lecture on different techniques for that. So once you've split up the fraction into partial fractions, then you integrate each one individually, and then try to use properties of logs to simplify it. So we'll take a look at some examples. Okay, this is not improper because the numerator is not of higher degree or equal compared to the denominator. So first we want to split it up. So we factor, and we would factor this as x times x squared minus 1, which is x times x plus 1, x minus 1. And for each of these factors, you assign a fraction. They're non-repeating linear, so you just need one fraction for each. Multiply through by the common denominator. So this is all math analysis here. All the math analysis. And you pick different numbers for x. You can pick anything you want, but it makes most sense to pick things that are going to cancel out these factors. So when you pick these different values, you can solve for your constants. So this again is the MA review. So once you've got A, B, and C, you plug them back in here. So you've decomposed the original fraction. And so now your integral looks like this instead. And you can integrate term by term. So you get 2 ln x, you get plus 4 ln x plus 1, minus 3 ln x minus 1, of course, plus c because it's an indefinite integral. And finally, we can combine these. We put the coefficients inside as powers. And if you're adding, you're multiplying in the log. If you're subtracting, you divide inside the log, and we can write it as one big log like this. Okay, this is a repeated linear factor, and so you need one factor per power. So we write it like this, multiply through by the common denominator again. You pick different numbers for x. 1 would be a good example. That gives you b immediately. And then pick any other number. 0 is usually a good choice then. And since you know b is -1, you can plug it in, and you get a. So now that we have these two values, we plug them in up here, and this is our new integral. Now keep in mind that it's not always logs. This doesn't require logs. This is just power rule. So this one's going to be a log, but this one is power rule, and we have our plus c. Okay, so a little bit more intensive here. We factor the bottom, and we can factor it into x plus 1 times x squared minus 2x plus 3. Now this cannot be factored further, so because of that, we have an a over x plus 1, but since this will be quadratic, we need to have a linear factor on top, so bx plus c. So this kind will not be on the AP test, but you will see it perhaps on my tests. Multiply through by the common denominator, and you get all of this. Again, you need to pick different numbers for x to try to solve for these constants. So I pick -1, we get a is 1. At that point, I plugged it in. I plugged in the 1, and now I've got to pick other numbers for x. So I pick 0, I get c is 2, and once I know that, I pick just 1, and I manage to get b is 0. And so here's our new integral. The left side is going to be a log. The right side is all of this. Now, to do this integral, you have to use trigonometric substitution. And so I'll just go down and show that whole solution here. But that's really not a part of this particular lesson. So here's our ln x plus 1, ln x plus 1. This integral becomes all of this stuff here. We've got to set up our triangle. We use the trig substitution, x, and there's dx, and when we go ahead and integrate that. And then once we get our theta, we reverse the process and get our inverse tan, basically. So that's a combination of a couple techniques. Okay, for this one, the bottom factors as a quadratic squared, and so it's a repeated. In addition to being repeated, it's quadratic, so you have one factor here, you have another factor for this pattern. These are both linear factors since these are quadratic. Multiply through by the common denominator. Notice we have a, b, c, and d. And so what's going to happen is we'll have 4 constants. And So what I chose to do was I just picked a bunch of different numbers for this. So just small numbers. I plug them all in, and I get these 4 equations. 1, 2, 3, and 4. And I put them into my calculator. I made a matrix, augmented matrix out of it, and I used RF. Boom, there are my constants. So don't do this by hand. You use some assistance, the calculator. So then I plug them back in up here, and I end up getting this. And so there's my new integral. And so the left one here is, I can rewrite in this fashion. The right one, use a u substitution, if u is x squared plus 3. So the left one becomes an inverse tan, and the right one, if u is x squared plus 3, it's power rule. And one more of these. Okay, this is now repeated. This is non-repeating linear factor, so this is now back to AP level, but we have an a as opposed to a number. So we split this up this way, difference of 2 squares, multiply through by the common denominator, and plug in values for x. So first negative a, and we get b is 1 over 2 little a, and then we plug in x is positive little a, and 1 is equal to 2 little a big A. So there's big A. So they're both 1 over 2a, which allows us to rewrite this fashion. I just brought the 1 over 2a out in front of the integral since they're constant multiples anyway. And since I got a 1 over 2a for both, I factored it out. This one, because it's a minus x, if you used a u substitution, you'd have to have a negative here. This one will just be ln a plus x, and I've got a plus c. And finally, you can combine these two into one log. Since this is subtracted, it goes in the denominator.